start this to so that you can start drawing this table.
For a second. Okay. First thing I want to tell you is that if you were to walk in the door before we talked today, and I said, what's the probability of getting heads or tails and tossing a coin? Most likely all of you guys would say 50-50. And that is not wrong, but it's also not exactly correct. Because 50-50 is a theoretical probability, which you probably don't know the actual definition of yet, but you will after today. Okay, a better definition, a better answer would be, I have 100% chance of getting heads or tails. That's a much better answer than 50-50, because when you toss the coin, it's not going to land on its side, right? You're going to have 100%. Okay, let's not do that. But it's not your fault. It's going to happen all chapter. People are like, what if the dice didn't know it? Okay, no, we're going to talk about fair, normal practices in our stats class. Although I do have a pair of loaded dice, which are fun. But anyway, but what I mean by that is, you know, your coin's not going to float in the air and be one or the other. You're going to get heads or tails. You have 100% chance of getting heads or tails when you flip it, is what I am saying. Does that make sense? Okay, so our goal today is to sort of figure out where that lies and where the 50-50 lies. Because the 50-50 is not wrong. It's just not really the whole story. Where are you guys in writing?
Want to give them the.
Okay. Ooh, nice. Okay, could I do this momentarily? Okay, so what I'm going to do is I'm going to use an applet that was provided by our book that's actually pretty cool. And here it is. What I'm going to do is I'm going to set the probability of heads as 0.5. So this is a fair coin. And I'm going to flip the coin. And then down here, it's going to give me the proportion of heads. Okay, do you see what I mean by it's actually more accurate to say there's 100% probability of getting heads or tails? Okay, because I didn't get 50-50 here, did I, when I tossed my coin? I got 0 heads. Okay, so what I want you guys to do is in the box that says toss and then 1, and where it says proportion of heads, I'm looking at this number right here. Do you see the number I've highlighted? Okay, so I want you to put 0 in that box. So we got 0 on our first trial. We're going to flip again. Okay, we got 0 again in 2 trials. This happens. It happens. It's okay. 0 again. Don't freak out. Don't get edgy. 0 again. There's nothing wrong with the applet. Please don't start to freak out. 0 again. Okay, now do you guys notice that your table jumps from 5 tosses to 10 tosses? So I'm going to say, I'm going to do 5 flips at a time. Okay, so now your proportion of heads is 0.3. So put 0.3 under the 10 spot. Do you guys see what I'm saying? Okay, the next value in my table is 60, so I need to do 50 flips at a time. 0.383. Okay, the next value is 110, so I need to do 50 more flips. 0.464. Ooh, it got worse. 0. Wait, no, don't write it. I have to hit it again. 0.438 for 210 flips. Okay, so now I'm going to do 100 flips at once. 0.448. Oh. 0.471. Okay, and just for grins, okay, so you guys are done with your table, but for grins, I'm just gonna keep flipping. Okay, if you took calculus, this is what we call a limit. So what is the limit as the flips approaches infinity? 0.5. Okay, if you're from math 3, straight from math 3, think of it like an asymptote sort of deal, but it's kind of like an asymptote. So when we describe asymptotes as something you cannot cross, which is false. I say that one time in math 3, you can actually cross it near the origin and then you get closer to it. So this is kind of an asymptotic thing here. But if you took calculus, this is a limit. Okay, so probability has an actual definition. Probability is the outcome of a random process between 0 and 1. Just going to say we all know that fact, but the number of tests that I get turned in with probabilities that are negative and over 1 is astounding. Don't do that. Don't do that. Okay. The outcome of a random process, like, I don't know, flipping a coin, somewhere between 0 and 1, that describes the proportion of times the outcome occurs over a long series of tries. Okay, so what I'm really trying to get in your mind is that you're not going to get that 50-50 with a coin until you do a lot of them. You have to do a lot of them to really get that 50-50. Okay, and then the other concept that is very much tied to this is called the law of large numbers. Over more and more trials, the proportion of times that a specific outcome occurs approaches, so there's your calculus word, approaches the theoretical probability. And when you think of the law of large numbers, I want you to think about this and how that was approaching 0.5. Okay, do you guys have any questions about what probability means or the law of large numbers means? Interesting concept, probably never thought of before. Yes.
Would it be wrong for a probability as percent, or should I just only write it as decimal?
You can write it as a decimal, a percent, or a fraction. They're all acceptable. I asked everybody in first period how many people drank coffee. It was way below 56%. But you guys aren't adults, so the probability that Mrs. Talbot drinks coffee on any given day is pretty darn near close to 100. I can't remember the last time I didn't have coffee in the morning. I really can't. It's like my first thing. I would like hit the thing on the Keurig, walk to the bathroom, like scrub out my night guard, go back to the Keurig. this is my daily routine. Okay, anyway. The probability that a randomly selected US adult drinks coffee on a given day is 0.56. So notice we've got some chapter 4 vocab in here. You need to know how this stuff works before you do chapter 5. Interpret this probability as a long run relative frequency. Relative frequency just means like a decimal. Okay, so we're going to do a percent. Over many trials, okay, so remember, it's repeated times, long run flips of coin, and this is long run random selection. So over many trials, if you took a random sample of US adults, not teenagers, apparently, about 56% of them will drink coffee that day. Trying to think about the math teachers. So I definitely drink coffee every day. Mr. Regalado definitely drinks coffee every day. Mr. Knight does not drink coffee. Yeah, Mr. Rice is on and off. Sometimes yes, sometimes no. Mr. Keppen goes on like these health kicks where he's like off of caffeine, but then he's like binges caffeine. He's on a wave. Yeah. Anyway, okay. Now, if a researcher randomly selects 100 US adults, will exactly 56 of them drink coffee that day? What's the chapter 4 vocab word that talks about taking a different samples of and the amount being different in each one? Sampling variability. Nice. Okay, so if I go out and randomly select 100 people, is it probable that exactly 56% of them are going to drink coffee that day? No. It's possible, but not necessarily. I don't know. If I got a simple random sample, it might be that I got all coffee lovers or all people that are allergic to caffeine. I don't know. Mrs. Talbot, Are you trying to sneak chapter 4 vocab into our chapter 5 notes so that we force the study? Ooh. Oh. Okay. Next thing we're going to talk about is what's a random process. Random process is how to have fun. Yeah, gambling. So a random process is a process where outcomes are determined by chance. What I'd like to do is come up with about 10 of those. 1, 2, 3, 4, 5, 6, 7. We got 7 in first period. Anybody have any ideas of a random process? Yes. I'm not going to say slot machine. I'm going to say RNG, which is a random number generator, which is what a slot machine is. But that's also counts your calculator. So now you don't get to say calculator and you don't get to say random number website. Those are all RNGs. Random number generator. Yes. Yes.
So it was like hat.
Hat. Perfect. Hat. I thought of that one. Nice.
Card.
Cards.
Roulette.
Yep. Wheel or spinner. My first period thought of one I hadn't even thought of yet. Yeah. Dice. Harrison, what'd you say? Coin. By the way, this is my YouTube video, and I'm telling Mr. Coin that you missed an opportunity to call your currency coins. I just want you to know that. Or just coins. We have 1, 2, 3, 4, 5, 6, 7. What? The one that my first period thought of, it's kind of like the marbles you were saying. So like I was thinking about that. They were saying like that bingo thing where it's like the big ball of thing of balls and you like turn the thing and it's like
But it's
basically a hat.
awesome.
It's basically a hat.
But it's awesome. It's awesome. Cool. Really? Yeah.
Anyway, I guess we can be done with that now. Okay, cool handle basket thingy. Bingo thing. Okay, flip your page or find a spot for a bunch of bullet points. None of them are long, I promise. It said cool handle basket thingy. It was really not important. You understood the, yeah, you know, but they said lottery also, and I was like, aren't we all saying hat? I don't know.
Yeah.
It was a great conversation that went on too long. So now, while you guys are setting up your bullet points, I'm going to talk to you about my favorite YouTuber, which is Vegas Matt. So Vegas Matt is this kind of a older white guy dwarf, and he is a millionaire, and he does YouTube video every day for about 45 to 60 minutes of slot machine gambling, high limit slot machine gambling. And I watch it, I would not say every day, but 5 times a week, probably. And it's like a train wreck, because you're watching this man lose extremely large amounts of money that I could be spending on so many things. And it's like, I could have just bought a car with that. I could have just gone to Disneyland 4 times with that.
Some goodness out of it.
Well, that's why you watch it on TV and you don't do it.
Well, true.
But he talks about statistics a lot and incorrectly. So, right. So he has a group of crony buddies, and 2 of them are pretty much math geniuses. Those 2 always correct everything that he says that's wrong. But 2 of the things he talks about are gambling myths. So the first is the myth of due. The myth of due. Something being due, like you haven't hit in a while, so it's due. And the other one is the opposite of that, which is the myth of hot. The myth of due and the myth of hot. I will explain those in a second. Just write those down. So these are gamblers' fallacies. Okay. And I literally just Googled Vegas Matt talks about hot and due. There it is, by the way. Yeah. And no, highly inappropriate. But if I find one where they do some good stats talk, I'll try to get a glance for you. I do have one video to show you. I talked about this so much last year that my stats talk got me a cameo from him as my end of year gift. Yeah, it's so cute. I'll show it to you when we have time. But the due fallacy. This refers to the belief that something is more likely to happen because it hasn't happened in a while. A slot machine is due for a big win. As a knowledgeable gambler, Vegas Matt frequently points out that machines operate on a random basis and previous outcomes do not influence future ones, which is kind of false. He actually doesn't say that. He talks about the machine being due all the time. But his 2 crony buddies that are math geniuses always have to be like, no, Matt, that's not how it works. Each one is independent. So, but it's funny to listen to. I do worry about the population that watches the video, and perhaps those people have not taken AP stats and they might think the material, but whatever. Okay, and then the inverse of the due fallacy is a hot fallacy, the idea that a machine or table that has been paying out frequently is hot and will continue to do so. This too is a misconception, as each play is an independent event. So, no, okay. If you have a big enough bankroll to hang in there, you should. But anyway, so for example, casinos will try to trick you. So one of my favorite games is Baccarat. Baccarat is kind of a weird card game that we do not need to discuss on the rules of, but you basically have 2 bets, player or banker. And they try to fool you by putting up a screen that shows you like the last 20 wins. So you could be like, walk up and be like, oh, the last 5 has been banker. I need to bet on player. But you have to ignore all that stuff. Did you see how many zeros we got in a row? Like that happens. You can't look at the screen, man. Now, if you're into Baccarat, you should know that banker has a tiny bit of an advantage over player every time, so you should always bet banker. But that's just beside the point. Okay, so the myth of due, we're gonna write long term runs happen. It's okay. Long-term runs happen. It's totally okay. The myth of hot. Each trial is independent. It's okay. The machine is not hot. or cold, not a thing. It just has to do with what random number gets generated when your finger hits the button, and that's it. Okay, now the last one is the other thing we need to understand about randomness is changing probabilities without replacement. And what I mean by that is something like the hat method. If you have 139 slips of paper in there and you take out one, so there's 100 and, 1 out of 139 chance of being chosen, and then that one's gone. So then it's 1 out of 138, and 1 out of 137, and 136. So you don't get confused by if there's no replacement, how the probability increases actually each time because there's less things in the total. Okay, so what we're going to try to do is a simulation. We've done 2 simulations already this year. The first one was the hand reaction time. Shh. And the second one was the coin applet we just did. But this says applet. I don't know what happened. It looks like a Q. But we're going to do one about baseball. Yeah, baseball in just a minute. A simulation is something that imitates random. It doesn't imitate randomness. That's not what it does. Imitates real world problems using random chance. I don't know if you guys noticed there were some simulations in your chapter 4 homeworks. Where in the book they gave you a dot plot and it said like simulated proportions. And then you'd like count how many dots there were. Anybody remember that? Like seeing simulated. So that's basically, they just used a random number generator to make the dots. So we're going to use our random number generator, which is your TI-84, to talk about baseball. I do need to make sure, do you guys know what a best of 7 series is? No?
No.
Okay, what I mean by a best of 7 series is like the World Series. So whoever wins 4 games wins the World Series. So the most that it would be is 7. Does that best out of 7 games? Okay. Anyway. All right. Anyway, if you get an FRQ, which we're going to do one today, maybe, I don't know what time this class ends.
35.
Okay, we're going to do part of one today. And we'll finish it on Tuesday. But it has some very specific steps. Okay, a simulation starts with a description of how to use a random chance process to perform trials. Ours is going to be technology based with a calculator. You define the outcomes. You choose a method. Defining the outcomes, I'll show you how to do that. Choosing a method is going to be technology for us. Record your outcome from your one trial. perform many trials. A lot of times we can kind of cheat. Did you guys see how I cheated on the applet? I had it do 100 at a time because I don't want to actually flip a coin 100 times. Also, the sound of it, can't do it. Can't do it. The sound of the coin flip. And then make some kind of conclusion. Okay, so your FRQ is located in your packet. It's right on the back of the stamp sheet. And we won't finish this, but I'll pick it up. You can still do the homework though. Aren't you excited? But we're gonna do as much of this as possible. Okay. In baseball's World Series, the first team to win 4 games wins the championship. The series might last 4, 5, 6, or 7 games. A fan who buys tickets would like to know how many games on average he can expect a championship series to last. I would want to know this too, because those tickets are super expensive. And I'd really like to go to 7 games. So I want them to last longer just for my money's sake. Except that the food is also extremely expensive. So I might, anyway, but assume the 2 teams are equally matched and set aside such potentially confounding factors as the advantage of playing at home. Fans want to know the expected value and underline this word. This is new for us. I'm going to say weighted average for expected value. Weighted average is like calculating your GPA, basically. Like this is worth times this plus this times this plus this times this. You know what I'm talking about? Like A's are, this is how many A's I have times 4. This is how many B's I have times 3. That's a weighted average. For the number of games that will be played in the World Series. Describe how you would carry out the World Series simulation on a calculator or computer. Okay, so I did a bunch of this for you. This is the defining outcomes part. Let a 1 represent team 1 winning a game and 2 represent team 2 winning. You will simulate 7 games, but as soon as one team wins 4 games, the World Series is over and you have to ignore any results that follow that. See below for an example. Okay, so this is rand int 127, which means this is team 1, this is team 2. Give me 7 games randomly. And this is the first game, team 1 won. The second game, team 1 won. Are you with me? The third game, team 2 won. Fourth game, team 1 won. The fifth game, team 1 won. And so then the World Series was over, and these did not actually occur because team 1 won in 4 games or 5 games. Sorry, team 1 won in 5 games. Do you see it? Okay, so I want you guys to write math probability rand int. Now, why are we not using rand int no repeat? Why does that not make sense here? Yeah, you want them to win more than once. So this is the lowest number we want it to give us. This is the highest number we want it to give us. And this is the total number of numbers. Okay, now find your graphing calculator and do one trial. Everyone's going to have a different answer here, but you need to analyze it to figure out how many games it took them to win. Oh, look, it's already in my thing. Okay, everyone should have something different. Don't write down mine. So you need to figure out which team won and how many games it took them to win from your calculator. If you're not sure about how baseball works or best of 7,
Weird. Remember,
but you got team 1 and 5 games.
yeah.
Did anybody else get something different from team 1 and 5 games? Team 1 is like, what the heck is happening in team 1? I got team 2. 7 games, 7 you got. Look at my.
Four?
Whoa, who had a sweep?
Harder.
I got 5.
Jada had a sweep? Mrs. Salbert, can you talk about sports and gambling every period? Yeah, I know. Okay, so this is where we're gonna end it. But I do want to show you my joke. Which how I ruined in my last video. Please read my joke. Please read it.
Just like so old, just like ruin my whole week. What? You know what I mean?
Oh.
It's just like yesterday she was like, can we talk? And I was like, I have an econ test. I have stats shit to finish. And I thought, I was just telling her I was like busy. She was like, okay, but just keep in mind, like, our friendship's more important than anything else you have to do. And I was just like, all my friends are like, oh, you're getting like manipulated by me. And I hate to say it, but it's starting to affect me. I might need to. This is not getting recorded. Did she hear that?
Oh no.